Welcome everyone. Thank you for joining us for our virtual workshop MATLAB for Engineers. My name is Krishna Prasad Mallampati and I am the Chief Executive Officer of Easysolve Private Limited. Today we are presenting Introduction to Fuzzy Logic using MATLAB presented by Dr. Chakravarthala Sivakrishnan Raju. Now, without further delay, we will turn the time over to Dr. Chakravarthala Sivakrishnan Raju. Our presenter today is an assistant professor in Department of Mathematics at GITAM University, Bengaluru. He holds a PhD degree from VIT University and MSc from SVU, Tirupati. He is an MATLAB expertise and teaching experience of more than 9 years. He is an author of 150 plus publications along with 3 books and a reviewer of multiple distinguished journals like Heat Transfer Asian Research, Engineering and Technology and International Journal, Computer Methods and Programs in Biomedicine, Journal of Molecular Liquids, Informatics in Medicine Unlocked, Results in Physics, Journal of Physics and Chemistry of Solids, Egyptian Journal of Petroleum, Journal of Geochemical Exploration. He is also a board member of Journal of Polymer Science and Engineering. He is awarded with Best Assistant Professor by Ijrullah Society and also acquired many appreciation certificates for his work. He has also prior invented lectures in esteemed organizations like VIT Vellore, VO Chidambaram College, MSP Mandals Vinayaka Rao Patel Mahavidyalaya, Vijapur District, Aurangabad, and Hindustan College. And finally, he is a chief advisor of Easysolve Private Limited. Over to you, Raju sir. Please take over the Google Meet platform and kickstart the workshop. Thank you, sir.
First of all, thank you for introducing me, Krishna Prasad.
Yeah, okay, sir. Thank you.
Just wait 2 minutes. And first, before starting my session, I'm going to give you the overview of my Easysolve, whatever the company they have started, the startup Easysolve. See, as of now, the most of the times, wherever you see the content in terms of, let us take an example as mathematics, because most of the time we feel mathematics is very difficult subject, so that we are unable to connect with the our main content like core domain. But whereas we started with the Easysolve that if whatever the content we are going to display, whatever the content we are going to teach, that should be some practical influence and it can be useful for the whole society. So that was the main intention that has been started. Until today, whoever has been started this company, they were in the final year now. Means they just completed the third year and then they are moving into fourth year. So this, and if you suppose if you are interested to do some internship or something else, if you are, you can contact in the Easysolve website so that you can. We are going to revise your resumes and we are going to allot some tasks and then we are going to provide the internships as well. So now let us, without delay, and let us start my presentation today. So as I told, today I am going to teach about the fuzzy. So there is a similarity between the fuzzy and the probability, because even in probability we are going to take the maximum probabilities from 0 to 1. The similar way, even in fuzzy also, whatever the function that we are going to assume, that we are going to convert in terms of 0 to 1 only. So that means that suppose if you have some idea in your mind that you want to implement and then you need to analyze without doing the experiment. So in that type of situations, fuzzy is going to useful for you. So see, first of all, see, in the most of the time, the people when they are starting their research, they are going to do from the basic level. But whereas now I am teaching you the traditional way of learning, because if you start learning from the basic level, when you start coming to research level, whatever the work and whatever the ideas you have, that is going to be published with other names. Means there is no guarantee that whatever the idea you got, some others will not get, right? So the same way, whatever we are going to teach now, there should be some practical influence, and then when you are starting your research kind of activities, you should start from the directly to the research. Then what happens if there is some doubt, if you are getting some doubt, then come back to the back. Then if you are doing in this way, the things are going to be fractuated, and then you can learn as much as fast, so that you are going to become the early researchers. So now today, as I told you, to open the fudgy, see here, see in other resource person, Dr. Mallikarjuna sir, he has been already gave the outline of and glimpse of the programming. Means how you have to start the syntax, how to code the things, and then how you can plot different kinds of plots by using the functions. But now I'm going to do only the simulation kinds. I'm not going to do any programming. So here first as already told you, we are implementing today fudgy simulation. So to open the fudgy simulation, see there are two ways. One is in apps we have here fudgy logic designer. So here fudgy logic, you just click on this, automatically it is going to open. But now what I'm going to do here, we have a shortcut as well, fudgy. Just type fudgy in the command window so that it will open new window. And before starting the fudgy simulation, we should remember few things. Like when you have some idea, let us take, I am assuming that I'm making clear once again, I am planning to predict the I am planning to predict the accidents possibilities. So accident possibilities I am planning to predict. Now I am making two possibilities for the accident. See, we have many reasons, but I am taking only two reasons. But for the simplicity, I am taking only two reasons, because when you are giving the rules, we have to make that how many parameters you are going to take. That many rules we have to make. It will take time to give the rules. So for that, what I am trying to do here, we are for predicting the accident possibilities. What are the main reasons? First one is high speed, right? Speed means speed also one cause for the getting the accidents. And other one is I am taking the alcohol. If suppose if someone is having the taken alcohol and then he is driving, so that there is a possibility of getting accidents. So now my initial assumption is I want to predict the accident possibility. And then for that causes are, what are the causes are going, what are the causes means accident, for getting the accidents, there are two reasons I am taking. There may be other reasons also. Suppose sometimes sleepy time, like he may be tired with some, and then he can, if you drive, there is a possibility of accidents. Then other possibilities, still there are many possibilities are there. I'm just taking the only two possibilities, speed and the alcohol content. Suppose if the person take drink and then if he drive, so that there is a possibility of getting accidents. In that also, I'm going to divide the regions. See now, when you click on fudgy, it is opened the new window, right? So here there is a option called, you are able to see right here. So input command and output both are there, right? And I hope you are able to see my screen, right? You are able to my screen. You are able to see my screen. Okay. So fudgy logic designer, is it fine? So see here now what I am trying to do, in the fudgy logic, when you type in the command window fudgy, it is going to display new window that is called fudgy logic designer. Now here we have to decide before putting into the putting into the simulation, we need to know what are the input variables, what is the output variables. Even in programming as well, we should know first what are the input variable, what are the output variable. Then only you can able to implement the programming. Even here simulation as well, similar kind. But now, if you see here, we have an input command and there is a Mandami approach. Mandami approach is for the non-linear data. There are three kinds of approaches are there, Mandami and Sugego and Takagi. Sugege and Takagi is going to for the linear data and constant data. But Mandami approach is for the non-linear data. We are going to apply. So now, as I already told you, my input parameters are speed on the alcohol. What is my aim? My aim is I am going to predict the accident possibilities by taking the consideration of speed and alcohol, right? So now I have to give two input variable and one output value, right? Output parameter. So now that, see here, what are the parameters that are going to take in terms of membership functions. And again in the membership function, whatever the region 0 to 1, in 0 to 1 in the sense that is nothing but in terms of percentage 0 to 100%. Now I'm going to put two variables here. As I already told you, speed, right? So I need to add the another variable here because we have only one, right? So in the edit, just see here, edit, we have options to add the membership functions. Yeah. Add variable. So either you want to add input variable or output variable. So now we have only two inputs and one output. So add input variable. So now it is going to change two input variables and one output variable we are going to get. And again, now we have to change the names, right? Here we have the default command input 1 and input 2. So if you click on this, if you observe here side, we have the options: current variable, name, time, and range, right? So give name for this. So what is our input variable? Speed. First one is speed. Then give second one. Just click on second one so that it will display here input 2. Replace instead of input 2, other one is alcohol. So now two input variable we have given names, right? And what is output variable? Output variable is here accidents possibility. So now, as we already discussed, we have been renamed with the what are the parameters we require. My aim of today's presentation is I want to predict the accident possibilities and with respect to by taking the consideration of speed and alcohol. So now again in the speed also we may be having the different regions. Means either it may be sometimes you may be dividing the region into trapezoidal and trapezoidal way or square way or continuous way. There are many types are there, but depends on the situation you have to select that particular membership functions. Now for the speed we need to add the membership function. See here, just click on speed, and then for this we need to add now membership function. Go to edit, in the edit, add membership functions. So now in the speed itself I am assuming again different categories, like suppose the region from 0 to 40 is low speed, then 40 to like 60 high speed, or medium speed, like can call it as medium speed, then 60 to 80 as high speed, then fourth one I am assuming 80 to 100 as very high speed. So now I have to add the membership function according to our assumption. Either wish, here we can take 0 to 50 as low speed, 0 to 50 to 100 as high speed. That your wish, because I am assuming here 0 to 40 as low speed, 40 to 60 as medium, 60 to 80 as high speed, and 80 to 100 as very high speed. That means now I need to add four parameters here, right? So now if you see here, there are already membership defaultly it has given three membership function with triangular membership function. But if you want to change the membership function, you can change. Even here we have an option to change the membership function, type of membership function, that is either trapezoidal or triangular or Gauss signal. Based on depends on your application, we have to take the your particular that particular membership functions. So now whatever we have here, I'm just removing in all the existing membership functions. I'm just removing all membership function from this. Now we have to add the four membership functions for this, right? So again go to edit, just add membership functions. If you want to add one by one, take custom membership function. So anyway, we fix with the triangular membership function at present. And how many membership functions you need to add means how you are going to divide the region speed, that you have to take, because we have divided that region into four regions, right? So just take 4. Now click here, click on OK. Then it is going to generate here 4 membership functions. Now we have to change the regions. Defaultly it is there 0 to 1, but here we have in terms of 0 to 100, right? So for that you have to change the range here. In the range, just change 0 to 100. Then automatically it will change things. Now, whatever the assumption we have made, low speed, high speed, medium speed, very high speed, those things we have to represent here, right? We have here membership function 1, membership function 2, membership function 3, and so on, membership function 4, because we have divided the speed into 4 categories. So now membership function 1, right? So 2 it is there, sorry. We have to take first one. First one is MF1. So MF1 is, what is the region? The region is from, for MF1 is 0 to 40. We have to give, for a triangular membership function, we have 3 points, right? The same thing, we have to give 3 values. So 0 to 40, we have to give 3 values. Means I'm taking 0 and 15 and 40. So then automatically it will change up to 40. Then membership function 2. Membership function 2 is medium. I'm giving 3 values because I have been selected the triangular membership function. For the triangular membership function, we are going to have 3 points. So we have to give 3 values. So now similar way, the medium speed, I am assuming that 40 and 50, 60. So this is the region medium speed. Then now, so remember MF1 was not changed. Again we have to change, right? This one MF1 was there. Just give rename as low speed, low speed, medium speed, and then now MF3 is high speed. Triangular membership with the data we have to give, that is high speed. We are assuming that from 60 to 80. So 60, 70, 80. So high speed. Sometimes if we can also take high speed as from 55 to 80 also, or 80 to, if suppose we have mentioned high speed as 80. Also sometimes we can call it as 75 to 100 also. You may feel that if it is very high speed, we can take that region also. So now MF4 I am taking as a very high speed. Whatever the data, whatever you are assuming in your mind, just present in terms of fuzzy, so that it will give you the output, whatever the way, convenient way you want. Means, see, suppose without implementing the experimental, we can come to know what are the changes in, if you change the speed level and the alcohol level, quantity, possibility of accidents, you can able to identify without implementing any experimental, without even, we are going to save the cost as well, if you do this kind of simulations. So here I am assuming 80 to 100, right? 80, 90, 100. So this is very high speed region. So similar way, we have to define the alcohol as well. So now here we have only 3 membership functions. Just you have to remove all this. So for removing, we have to go to edit and then remove all membership functions. So now it is removed all the membership functions. Now we have to add the membership functions because we already given there 4. So here we can give 4 membership functions. In the alcohol quantity also, sorry, already it was there, right? Okay, yeah, alcohol quantity, yeah. Alcohol we have got 4 membership functions. Here also we have to divide the region. So here also what I'm assuming, like 0 to 40% is low level, 40 to 60 is medium level alcohol content, 60 to 80 is high level alcohol, and 80 to 100 is very high level alcohol content. So now we have to change accordingly, right? So now membership function 1 is low level alcohol, low level So first, before don't forget to change from range 0 to 100. So we have to give 0 to 100 as the region. So once you have given 0 to 100, then click on here. Low level first region is low level. That region is from, we are assuming that 0 to 40, as we have selected the triangular membership functions. So we have to give the three values 0 and 20, 40. Then next membership function 2, we are taking as medium level. So that is medium level. So here we have to give the data 40 to 60, right? 40, 50, 60 is a medium level of alcohol content. Then membership function 3 is high level. So the region is parameter, the range is from high level 60 to 80, 60, 70, 80. I'm taking three values. And last membership function 4 is very high or very high level. What is the range we are assuming? 80 to 100, right? 80, 90, 100. Now the entire region is covered with the, in terms of triangular membership functions, even speed and alcohol. The way, whatever the way we have given the regions, the same way we have to give the accidents as well. So now first remove whatever the membership functions are existed here. Just remove all membership functions by going to edit file. In the edit, we have remove. So if you are selected file only, if you want to remove, just selected file, or if you want to remove all the files, you just select remove all membership functions. So now we have to add the membership functions for the output parameter, that is accident possibility as well. So now add membership functions. So here we are adding the even output also, we are taking as four membership functions. Then see, automatically it will go to the first one. So all the time we have to check here whether you are working on whatever the your selected one or not. Because see, if when you click on here, when you added here, automatically it went to speed, because already it showed you low speed, medium and high speed. That means that it has been went to for the starting one. Then you have to come to whatever wherever you want to change. So now in the output variable also, I am taking the regions as low possibility of accident, right? Low accident possibility. Low accident possibility is, first before that we have to change the region. Sorry. So 0 to 100, right? There we have converted 0 to 100. So here also we have to convert the 0 to 100. Then here this region is low accident possibility is from where to where. If suppose we may be assuming that same level of like 0 to 30 is low, means there has not happened any damage. 0 to 10, 20. Then membership function 2 is medium level accidents, medium level accidents, medium level accidents possibility. We are assuming that already there 20 over, so we have to take the 20 and 30 and 40. So now high level accidents. So here high level accidents in the sense above 40 to 80 we can take 40, 40, 60 and 80. Now very high in the sense very high possibility of accident, very high accidents possibility is 80 to 100, 80, 90, 100. So now we have been given the output variable and input variables, all the values we have been given in terms of membership functions. I will explain you the theory as well. If I explain mathematical theory, most of them are going to get bored. That's why initially I'm giving you the glimpse of what are the application of that particular fudgy or membership function, so that you are going to get interested. Then whenever whatever I am going to teach in terms of mathematics, we are going to get some interest on that. So now I have been what I have done as of now. I'm repeating. I have just in the command window. I just type the fudgy. Or other way is you can go to in MATLAB apps. In the apps, in the control system and design analysis, there we have the fudgy logic designer. Just click on that so that it is going to display the window what we are seeing now. Sorry. Yeah, fudgy logic designer. Yeah, here what we did, we just added the input parameters and the output parameters. So before see whatever you have in mind, that you have to convert into in terms of membership functions. First you need to take the parameters, from then you have to go for the membership functions, like what is the regions you are going to divide that particular parameter. So now we have been done. Next we have to add the rules. What are the rules? Rules is nothing but, see, speed is this much, alcohol is this much, what is the possibility? Speed is this much, speed is medium, alcohol is low, what is the possibility? These rules you have to assume according to your wish. See, what are the things we are going to do here is your assumption. Whatever you are going to assume, the based on that only this is going to give you the results. At the end output also based on that only it will give us. So now I'm going to add the rules. If you see here in the view, rules, the option was there, just click on rules. So if you just click on rules, it has to come, it is not, yeah, it's not getting, yeah. Sorry, let's close this one. So here in the edit also we have, sorry, in the edit we have rules. Just to click on rules, it is going to open in a new window. There, whatever I see, what are the parameters we give that has been converted into in terms of simulation. Just you have to select here. See, if speed is low speed, if alcohol is low level, the accident possibility is low accidents possibility. So you have to add the rule. So if you want to add, just click on add. So automatically it is going to display here. The rule is going to add it here. See, if speed is low, see whatever assumption we made that has been converted into like general English, right? So in the same way, if speed is low, alcohol is medium. Alcohol is medium. What is the possibility of accident? We are assuming that there is a low level accident possibility. So just add low level accident rule, another rule. So if speed is low, if alcohol is very high, accident possibility also high, right? So high level. Then add rule. If speed is low, if alcohol is very high, then what is accident possibility? Very high also. There may be possibility, right? So in the same way, we have to select all. If speed is medium, if alcohol is low level, accident possibility also low. The same way, if speed is medium and alcohol is also medium, and accident possibility also medium. We are assuming all these possibilities. And speed is medium and alcohol is high, and accident possibility also sometimes it may be high only, right? High only and high. Then similarly, if alcohol is high level and very high level, and accident possibility also very high. So then similarly, if speed is very high and alcohol is low level, even though if speed is alcohol is less, sometimes the accident possibility also medium level. So add rule. If speed is very high and alcohol is medium, So there is a possibility of high possibility of accidents. If speed is very high speed and alcohol is very high, then a very high level accident possibility. The similar way, we have to give the rules. Very high, low accident possibility is very high speed means there is a possibility of high speed. Then very high speed and alcohol is medium, so very high accident possibility. So very high speed, high level alcohol content, then very high speed, high possibility of accidents. Then very high, we are going to get right. So this is the way we have to add the rules. So once you done the added the rules, then what we are going to do is see now, see, suppose if you want to change any rules, so you just click on that and delete the rule. We have option here. Suppose if you have given this by mistake, you just see the rules. See the rules, whatever the rules you are going to add, that are main important for your output. Whatever the rules you have given, that only it will display in the output as well. So now see here we have the two options, right? Connection, the connection we have or and options. Or in the sense, suppose either this one or this one, then what is the possibility? So now we have selected here and in the sense it has to satisfy the both the conditions, then this is the possibility. That is the way we are given here. So then the similar way we have to add, if either if you are working on R operation, just click on R. If you are working on AND operation, just click on R. That is, it depends on up to you how you are going to take the rules. Then once you done the rules, then you have to see the rules viewer. Yeah. Yeah. See here we got rules viewer, right? So now what are the rules we added? That the possibility, if speed is 50, alcohol is 50, then accident possibility is 30. So this has been clearly understood, right? How, if suppose if you want to change, see here, if I change the speed content, if speed is 14.2, alcohol is 50, then accident possibility is 10. Means once we have divide the region, whatever the region, in terms of speed and the content, then the accident possibility is also giving the in terms of probability. This whatever we are getting, this is the in terms of probability, is it is going to generate this generally, means whatever the assumption we have made, based on that only it is generating the possibilities as well. If suppose alcohol is, if you select 14, then what is the accident possibility? See, these are whatever the rules we are being added. If you add more rules, you are going to get the exact content of if you add perfectly the rules, so that the output also you are going to get properly, how you are going to observing the scenario of practically the same scenario we are going to get here. So now once you see, if you suppose if you select somewhere say medium, if speed is 46.3, alcohol also is suppose 43.2, then accident possibility is 30. Then what is very high possibility? Just click on speed is 73.9, then alcohol is 43.9, then accident possibility is 60%. Then if both are speed is 73.9, alcohol also 66.98, then accident possibility is 90%. Means speed is above 70 and alcohol also is having the more than 66% of quantity, then accident possibility is 90%. So the similarly, if you see the speed is 87.6 and alcohol is low also, like alcohol take as low level, then accident possibility is 60%. So then if you take 90, speed is 93 point something, then alcohol is low level, then accident possibility 60%. If suppose alcohol also medium level, then what is accident possibility? 60% only. Suppose if you change 43, this has been generated based on the rules what we are added and whatever the membership function that we have done in the like initially we assumed the input parameters and output parameters the same. Based on that only it is going to generate the output here. So now the same thing, if you want to generate in a three-dimensional plot or something else, like if you want to generate, if you want to project the result in a different way, different kinds of projections, like just 1 minute, sorry. if suppose we want to generate these results in terms of surface without generating this, like suppose if you want to know the exactly how the behavior when you plot something in terms of surfaces, then it is clear, right? See, now just click on surface. If we want to get the surface plot, we have to go to view. In the view option, we have the option called surface. Just click on surface. It is going to open in a new window. Surface, it will take time. Yeah. So now here, if you see, we have the options again. We have the options again. Just 1 minute. It is taking time to upload the graph. So here, if you see, we have X input and Y input and Z input, right? Sometimes if we have a two output also, we can give the two outputs as well. So that is in the initially only we have to assume, and then we have to create, and we have to give the results. Now, so if you see, suppose sometimes you want in x-axis as speed. See, it is mentioned that clearly x-axis is speed, and y-axis it has taken alcohol, and z-axis it has taken as accident possibility. Now, if you want to change, I want x-axis in alcohol content. Like just take alcohol as x-axis and y-axis is speed. Automatically, it is going to change, and the accident possibility also will protect automatically. See, this is the accident possibility, and this is 0, 0. Then what is the possibility of here? See, 20%. See here, 50. So with respect to this, 50 here. So then in by z-axis, we are getting this is the regions, right? So medium level. So this is the way. You see, we just started with the some basic assumption that we want to predict something accident possibility. Then with respect to that, we have been assumed the two parameters. See, if you take the more parameters, we are going to get more parameters as well, and the plots also will vary, and the rules also will be more. See, I just given only two parameters, we got this many rules, 16 rules. If you add some other parameters like speed and alpha, other than these two, suppose if you feel that some other content of, see, suppose some sleeping mode also, sleep tiredness also will plays an important role in the accident possibility. If we add the tiredness also again, tiredness is the input variable. In that again you have to divide the regions. Then if you add that tiredness as if you plan to add that, if you add that, then in the rules it is going to display three windows, and then with respect to output possibility one. With respect to three, see now we have only two. That's why we are taking only two. If suppose you have tiredness also, here you can take tiredness with respect to speed and alcohol with respect to tiredness. So all these possibilities can be done without implementing any experiment, only the simulation. Because the main motto of this is, explaining this simulation is because now we can't go for the experimentation, because whatever the situation we have in the present day, it may come in future as well. So in the home itself, we can do the lot of project like simulation kind of things. You can do the what is a small project you can implement, so that whenever you get started with the normal life, then you can implement the things, then you can get it published in a good journal. See, when you have a theoretical as well as the experimental values, the experimental validations, if you have both the validations, then the work is going to be high worthy. Then it is going to go for the high journals as well. So that's where we started with the like basic assumptions, and then we are going with the theoretical simulations, and then we moved into finally the whatever the assumption we made based on the results. So now with this, now if you want to save this result, we have option here. Anyway, already sir has been explained you. If you want to save this, just if you want to save this file, click on import. Whether you want to save in export to workspace or to file. So just space the export to workspace in the sense the MATLAB workspace. So what is the variable name? Current type variable name. I am going to give some accidents possibility. Then click on OK. So now if you want to copy this figure, and you can copy as well, export to or import to, sorry, save, right, control save to file, where it went. options. So here we have options. Sorry, it is taking a minute. One minute. It's not responding. Yeah. Yeah. You have option to save file. Just click on this, and then in the fuzzy simulation, I am saving this accident possibility. So this figure automatically saved in our file. Just see here, FIS format, accident possibility FIS here. See here. In the fuzzy simulation, my current folder is MATLAB fuzzy simulation in that accident possibility FIS. This is figure we have been saved. Now, so once you're done with this, then see, this is the way we can. So suppose sometimes if you feel that if other type of plots, you just see here, we have other type of plots as well. The plots lit surface. Just see how it is going to be the lit surface. And if you want other plot like mesh based grid, see how it is. So if you want other surfaces like contour plot, just see whatever the data we have been assumed and then we have been inputted and then we have given the output variables as well. Then it is going to given the based on our assumptions, the results are generating here. And then just click on pseudo viewer. See, this is the pseudo viewer. Then if you want other viewer, even if you want viewer, you can get the viewer as well. So this is the way viewer also there. So better to have surface plot because it will be understandable for us. So this is the way we can implement whatever we have in our mind that is going to be converted into in terms of fuzzy simulation, and then we are going to get the output as well. So this is the way we have to do by using the fuzzy. Now let us go to the introduction part of the fuzzy, and then we will get to know how the calculations are going to be done inside the fuzzy. So this is the fuzzy rules viewer, and this is the rule editor, means what are the rules we have been added. Started with the by adding the input and output parameters. I hope this is understandable, right? So then I hope, is it understandable, or shall I repeat once again? Give anyone response so that I can proceed in terms of mathematically. Is it okay? Okay, then shall I move for the next level in terms of mathematics level? Okay, what is the mathematics behind this? So that I am going to explain you now. So let us go to the other part of presentation. You are able to see the PPT now? PPT is fine?
Yes,
Okay.
sir.
Fine, 1 minute. Just taking time. So now, so like, as I already told you, fuzzy and the probability have the similarities. Like both have the same properties. Like whatever the content and in terms of functions or in terms of data we are going to give, that is going to convert into in terms of fuzzy form, that is 0 to 1. So fudginess is nothing but whatever the idea we have, that unconciousness, like we don't have the clarity about that, but still we can implement in terms of fudgy and then we can get the results. That is called fudgy. The same thing have been mentioned. So today topics I'm going to cover you like what is fudgy and why fudgy, and types of membership functions and defudgification methods and fudgy inference system, fudgy logic controller, and one application problem. Application problem in the sense, as I already told you, the example. Then why fudgy? So as I already mentioned, the fudgy is always get you the confusion. Like it talks about the things which are not uncertain, like inherently vague. Means we don't know whether it is going to happen or not happen, but still you can implement by using the fudgy. That's where the fudgy is going to be help you to get things. Like even still today, what are the things we are going to do with the artificial intelligence or machine learning? What we are going to do, the things whatever have been done already, those data we are going to take, and then we are going to train those data, and then we are going to predict what is going to happen. This is the type of situation we have to give this type of response. This is the type. This is the way. If suppose someone is responded, we have to give this is the response. So that is the way it is going to generate, right? Artificial intelligence or in terms of machine learning. So the same type of things you can implement by using the fudgy as well, right? Because here we are not putting any money, right? Just simulation, just we have option, then just click on one fudgy option, then automatically it will display how many output parameters, how many input parameters, all those things you can implement, and then you can get the, based on your assumptions, the results. So once you see why you need fudgy, like see, most of the time, if you are a civil engineer, if you are a mechanical engineer, most of the time you may be come across with the different kinds of materials, so that you want to improve the heat transfer of that particular material or something else. Like so that, see, if you take some combination of material properties in this percentage of regions, so that we can get the output as how much heat is transferred from. If you take the combination of copper and aluminum, what is going to happening? Copper with other parameter, what is happening? If you take the percentage of quantities, so you can analyze without implementing the experimentally. See, if you want to implement in terms of experimentally, it will take a lot of expenses as well, right? So that's why, see, when you are having the present situation, we can't go for the outside as well, even we can't do any experiments as well. So this type of situations, what we can do is, like, we can implement in terms of simulation. Then when you're coming to the normal life, like when your usual life, then we can go for the experiment. Then when you have the theoretical values as well as experimental values, there is a possibility of getting the good publication. Like as you know already now, the recent trend is moving towards the research. So we need to know the what is the research and what type of articles are available, and the quality of the articles, all the things come into the pictures. So now, as I already told you, fudgy is nothing but just fudgy talks about the things which are not uncertain, like inherently like we don't know whether it is going to happen or not happen, but we can implement by using the fudgy. These are the example. For example, the boy is intelligent. How intelligent? Whether intelligent or not, we don't know, but still we can identify the boy intelligent or not by taking the some parameters, input parameters and output parameters. So that is the way we can able to get. This is fudgy. So uncertainty and fudginess, as I already told you, uncertainty is nothing we don't know, but we can implement. Fudgy sets and the probability. As I already told you, there is a relation between the fudgy and the probability. The traditional method of solving the uncertainty is called as stochastic process. If you see in the recent days, we have been come across with the stochastic process. What is stochastic process? Stochastic uncertainty. Uncertainty means we already knows that whether it may happen or may not happen. We know still, but still we can do by using the simulation that. See, as I already told you, the combination of materials. If I want to predict what is the conductivity of the particular material, if you take the combination of materials, so that it is going to process very fast in some industry. So in that cases, what you have to do, you have to go for the stochastic process. In that, if you start implementing by directly in experimentally, like by putting the combinations, by taking the parameters in experimentally, if suppose it has get failed, then what is going to happen? Whatever the expenses you have gained, that entire things are going to be wasted. So that's why in the recent days it has been popular. Stochastic process has been come into picture in recent days. It has a huge applications in various fields, even in artificial intelligence, even machine learning and deep learning, even data science. Wherever you go, stochastic uncertainty or stochastic process plays an important role. Then now, then who is what is fudgy and who has been introduced? Fudgy set has been introduced. Professor Lofi Jade in 1965. He is an electrical engineer and artificial intelligence person and a mathematician as well. He has been done in 1965. Still, we are studying the same concepts, right? He has been taught something. What is his mind? Whatever he has in mind, that is converted into terms of sets. That then converted into membership function. Then then later on it has been developed until today. What we have using in artificial intelligence as well is Pudgy sets. Generally, these are some small examples. We are taking some u is equal to, this is the set, and x is equal to some values. According to classical set theory, we can say that the x has the how many elements? If you see here, 1, 2, 3, 4, 5, 6 are there, so 6 elements. If you want to find the complement of x, what we can do? We are going to take the u minus x. U minus x, if you take, so 7 to 12, it is going to cancel, then remaining values are 14. So we are going to get the 14 elements. So now if you take the complement, this is you are going to get U1 universal set. So now what is my question is, I want to identify I'm assuming a value as close to 10. I want to identify the closed values of 10. So now what are the elements of 10 now? This is the question, right? So now there is a possibility. I'm representing whatever the assumption we are making. See, now I want to calculate the what are the elements close to 10 that we are converting, and then we are giving the with probability percentage of level. So 9, see, 10 definitely belongs to A. Belongs to in the sense that is this 10 is there in the A side compulsory. Definitely 10 is belongs to A. Then what is the possibility of close to A? Close to A in the sense 9 belongs to A. The possibility is 0.9. Similarly, 11 also we have, because if you see 10, left side we have the 9 and right side we have the 10, 11. So that means these two are going to have the probability of 0.9. 0.9 in the sense 90%. Then next later elements are 8 and 12. 8 and 12, the possibility is 0.7 and so on. This is the way he has been given the about the fudge sets, and then why he has been given in this way. See, if you see the image processing, sometimes you need to identify the some, like suppose I want to identify the near to I. So we have the when something happened, like some what you call some like some, I am not getting exactly, like thieves. Some thieves has come to bank, and then they have been stolen and whatever the amount is there. Now we need to identify there who is that particular person. So sometimes what happened in the cameras, we maybe captured some small images. So now that particular that image, what we are going to do, nearest to that values, we are going to check the possibilities, right? How much percentage of possibility is getting with the exactly matching with the already image, whatever the image you have and whatever the image you have. So if it is closest, if it comes to closest also, we can easily identify that this is the person has been stolen in this particular amount in this particular bank. So to conclude that way, it has been started for GSET, then it has been developed a lot now. And this is the mathematical expressions, like we call x is element and mu j of x is the membership function of degree of the membership function of x. So the same thing we have given here, the closest A. And if you convert that into in terms of graphical representation, we are going to have in this way only this possible, these regions like 5 to 15, only 5 to 15 region only, we are going to have the maximum possibility, and rest of the regions we are not going to have, because 5 to 15 in the sense there may be a 50% is concerned with the whatever the image we are looking for. That means that 50% is we are looking whatever the looking properties are matching, so that you can keep side, then we can identify from that, you can consolidate as well again. So this is the way it has been started with the first, it has been started, then it has been converted now into in terms of graphically. When you look at it graphically, we can easily get how much like how much important it is in practically. Then this is the way we can represent. Suppose if you have the interval type of kind of data, then we are going to see like it's like just a representation of fudge sets in different levels. So now here this is the fudgy normal fudgy set is maximum, at least host with that membership function value should be one in the sense that is 100% here. We call it as. So now types of membership functions. There are different kinds of membership function that we are, even I showed you when the simulation is happening. I told you about the triangular membership function, right? So in the triangular membership function, the things are going to be done in this way. See here, this is the triangular membership function. Like suppose, see, this is the triangle, right? We have the elements A, B, C. So now right, y-axis we have taken the membership function mu. Mu a of x is defined as, if suppose x less than a, then we are taking the value as 0. Means less than a value, we have taken this side values are 0. Then now we are assuming in this region. In this region we have the value. Then what is the value of mu? Mu is x minus a by b minus a. Then if it is b and c in this region, what is the value? So c minus x by c minus b and c less than or equal to x. If it is greater than this region, c greater than region, also we are going to say that there is no possibility. As I already told you in the graphical representation of basic example, the similar kind here means we have been assumed the triangular membership function, the particular place we have been highlighted within that region, whatever we have, there is a possibility some value, and rest of the regions we are going to have the 0. Then let us take an example and then look at them. Suppose they have taken some A value is 3, B value is 5, C value is 7. Then how we need to identify the membership value corresponding to X is equal to 4. So then if you see 3 is here and B is 5, right, as per assumption. C is 7. So that means now 4 is in between here. If you take this side, so the possibility of Y is we have some membership function value, right? That value we need to identify. What is this value mu? So further, see, as I already told you, within this region, in the sense, we have to take these three values, that is x minus a by b minus a, x value is 4 minus 3 by 5 minus 3, so that within this 3 to 5, in this region, we need the closest value is possibility is 50%. So suppose 4 is there in the 3 to 5 in between. So 3 to 4 we have 50% and 5 to 4 also we have 50. So the total 0.5. The membership function value is 0.5. The similar way we can calculate the trapezoidal as well. If you see the trapezoidal curve also, less than this region is 0 and greater than this region is 0, and then rest of the cases we have the values formulas. So this is the way, because here we have given 1. Why? Because B to C we have the maximum, some slope, right? The maximum possibility we are going to get in the trapezoidal curve only this B to C curve, right? So this is the B to C curve points we are going to get the maximum possibility, that is 100%, and the rest of the cases we are going to have the minimal values. So this is the one example. The same way bell-shaped curves, this is the membership function value. For this derivation, again it will take one more part, like 1.5 hour. So I'm just giving the what are the member type. There are different two types of membership function. How you are going to calculate the regions. And then now, what is defudgification? Defudgification is mainly for, just I will show you the by defudgification, then I can come back to there. Defudgification methods are maximum principal method and centralized method and weighted average methods and mean max methods and centers of sum. These are the some methods that are available for the defudgification. Defudgification in the sense we are going to calculate the what is the maximum value, what is the average value. That depends on you how you are going to project from that particular value. For that we are going to use defudgification. So here this like defudgification is the process of representing a fuzzy set with a crisp number. That means numerical value. That is called a defudgification. So now, for example, if you take suppose you have given some set, now you need to identify the what is the temperature, high temperature in this set. So we can say simply by saying this 50 is 0.9, 90% possibility is 50. The same way we can like even if you see the low temperature, if you want to identify from this low temperature, then we can easily identify from this. So we are going to have the value for that particular position. That is called crisp value. Then this is also done. Then next to see the application problem. As I already told you, here I have given the other example that to design a controller to determine the wash time of domestic washing machine. Now, previously I have given the example of the accident possibility with respect to two parameters, that is speed and alcohol. But now what I am trying to do is I am giving the next application by taking the what is the practical problem. Like usually most of the time we are going to use the washing machine, right? So in that washing machine, how it is going to take the project? Like suppose if you have a dye, and sometimes you may have some those who are working in the companies, they may be having the grease as well. So if they come across with the grease and then that both, if you have some different levels, then what is going to happen? Like as I already told you, the same kind of example. I'm just identifying how much that particular washing machine will take if you have the only dirt is low and grease is high, dirt is medium, grease is medium. What is how you are going to calculate this thing? That I'm giving the example. Like we are identifying the what is the mathematical background that we are going to I'm going to give you now here. Just see here, input variables are dirt and grease, and that only we call it as linguistic variables. Linguistic variables in the sense we have to convert the region into three parts. Like means not only three parts, that depends on you how many parts you are going to convert linguistic variables. Here we have taken as three parts, like low dirt, medium dirt, and high dirt. The same way grease also, low grease, medium grease, and high grease. And output variable is our wash time. How much time it is going to take that particular if you take the different compositions. Then here in the wash time also we have very short time, medium, and high, very high. Here this is our wish. We can take whatever level we want output variables, right? So now, as I already told you, we have been given the input variables and linguistic variables according to that output variable, and output variables also linguistic variables. Now, so we have to give the membership function. We already given right regions. So membership function for the input variable dot. So initially we have been selected some membership function dot. In that again we have been divided the region into three parts in the triangular way. So now here if you see the triangular function membership function mu LD in the sense low dot. LD of X is nothing but, so here we have 50, 0 to 50, right? Low region. Here, according to this, here we have given right 0 to 50 is low region. So for this we have what is the formula? 50 minus x by 50 minus 0. Then similarly for medium, if you see medium here, we have from 0 to 50 also medium and 100 to 50 also medium. Sorry, 50 to 100 also medium, right? So because some part is there in the 0 to 50, some other part is there in the 50 to 100 also medium part. That's why we have given here two medium dot values. So new membership function for medium dot of x is, if you take the region from 0 to 50, x minus 0 by 50 minus x, and if you take other possibility, that is 50 to 100, then 100 minus x by 100 minus 50. This is the whatever we have been implemented in the simulation, the mathematical background, how it is going to calculate it, how it is giving the results, how it is generating the output. That's I'm giving you here. And then similarly here, if you see high dot value is, if you are assuming that high dot value also we may be having sometimes 50 to 100. So 50 to 100 in this region, high dot value is, if you assume them, so that you are going to get the formula as x minus 50 by 100 minus 50. Why we are getting here 50 minus 50 only triangular functions? Because we have been assumed that we are going to generate the this triangular membership function. The formula for triangular membership function is, as I already explained you here, triangular membership function, right? See here, I already told you, right? Yeah, see here. So the same way, this is trapezoidal, this is triangular membership function, right? The same way we are applying here. This is less than region is going to zeros, and then greater than values also are going to 0. Then this in between region only we have some values. So this is the same way we have to give the input variables for the grease as well. Just a minute, sir. So, so now we have already given the input linguistic variables for the dot. The similar way we have to give linguistic input variables for the grease as well. In the grease also we have been converted into in terms of triangular membership function. And then if you see here low grease possibility, this is the possibility, and medium grease, and medium grease, as I already told you, 0 to 50 and 50 to 100, and high grease 50 to 100. These are the possibilities. So next, then what are the output variables for last time? So output variable we have assumed there very short, medium, high, and very high. So here also they have given region from 0 to 10. They are assuming this just. So 0 to 10 in this region, for if you apply the triangular membership function, we are going to get 10 minus z by 10 minus 0. Similarly 0 to 10, sorry, mu short, right? Sorry, mu yes. This is very short. This is short. This is type mistake. Sorry, this is. Okay, sorry. Short is there in the here and here as well, right? Short level region is there here and here. That's why we got here two shorts here. The output, US of Z and US of S in the sense short value, short time, like short time. How short time? How like in this region? How the machine washing machine will take less time, like short time. How much time will take, like washing machine, how much time it will take? That's what we have mentioned, vast time, how much time it will take. From this region, if you have the possibility is this one, if you have this region again in the very short time, because here also we have the short and very short. Similarly here also we have 10 to 25 also we have the short value. For that also we have to calculate. For medium also we have two possibilities, because here and here both. The same way high also we have this region and this region, and very high also we have only this region. So this is the way we have to calculate the it is going to generate the output variable. Sorry, I'm giving the background of like mathematical background, right? So then the next level is like how you are going to form a rule. So now what happened in the rules? In the rules, what you are going to do? Like we are as we already assumed, there are two parameters values: grease and dirt values, low grease and medium grease and high grease, low dirt and medium dirt and high dirt. So the possibilities, like if I am assuming that low dirty, if you have low dirt and low grease, the possibility of accident is very the possibility of washing machine to take the wash that particular is the time is very short. The same way, if you take low dirt and the medium grease, then the possibility for to wash the particular cloth is medium time it will take, and low dirt, and if you have high grease, then the wash time will take very high time. Then medium dirt, and we have very short sorry, and we have low grease, then the possibility is to wash your cloth is short time. And medium dirt and medium grease, there is a possibility of medium time. Medium dirt, high grease, the possibility of high high time, like a high wash time to wash your cloth. And high dirt in the low grease, medium we are assuming high dirt, and medium grease is high dirt and high grease is very high. The same thing we have been explained here. This is the way we have been formed the rules. So now how mathematical background, as we already told you, like same, right? 50 to 100 medium, because we have the medium is here and here. Now see, I want to evaluate. See, once you've done, you have been done the evaluation, like rules evaluation, right? Rules you have given, then how you are going to calculate. Now I want to calculate the, suppose my cloth does that is 60% and grease is 70%. If you write in terms of trapezoidal function in the membership function form, this is the way we are going to get, right? So now here we have the different regions. See, so 60, that is 60, right? In the x-axis we are taking that, right? That here that is 60% and grease is first that. Sorry, first we are calculating for the that. I think that. Yeah, first that for that is 60% means we are going to get 60 as in between 50 and 60 somewhere here. So now we have to calculate in this region, right? That is medium, right? So medium value of x is equal to 100 minus x by 100 minus 50. The same, if you calculate this particular, if you substitute in the place of x value 60, we are going to get this the value. The same way for high dirt. High dirt also we have means just in high dirt also we have the possibility. I think it is not required, right? So sorry. 60 was there in the high dirt as well. That's why we are also calculating high dirt as well. There is two possibilities it is going to calculate, like 4 by 5, and here also in this region also 50 to 100. Also we have the another high dirt value, that is x minus 50 by 100 minus 50, that is 60 minus 50 by 100 minus 50, that is 1 by 5. The same way we are going to calculate for the low grease and grease percentage 70%. 70% is come same way, like here this is the region only the possibility for medium and high. Calculate the medium and medium values and high values. As we already explained you, 50 to 100 and 50 to 5 means one time we can apply this formula, one time we can apply this formula, and both the values we are going to get, and then combine those rules accordingly, like take the cross product of these values, like medium dirt, medium grease, medium dirt, high grease, high dirt, high medium grease, and high dirt, high grease, means what are the possibilities, permutation values. So we have got that, we have been mentioned in terms of rules. Then just the so that value, what are the values we have been calculated here, we have mentioned here. Medium, high grease and medium values, right? Medium dot value possibility and all these possibilities we have mentioned. So here minimum means by this process is called differentiation. So we are calculating min max operator, min max method we are applying to calculate the differentiation values. So here if you apply 4 by 5 and 3 by 5, so the minimum value is in this 2 3 by 5, and minimum value from this 2 by 5, the same way we are calculated here. And the maximum method, right? So 3 by 5, 2 by 5, 1 by 5, 1 by 5, this the medium value is 3 by 5. So medium dot 3 by 5 is for medium dot, sorry, medium dot and medium grease. We have to check in step 3. If that is medium and grease is medium, then wash time is also medium. If that is medium and watch time is medium, then possibility of watch time also 3/5 possibility, like, so we are getting the time also is medium. So here mu of membership function of z step 2 is z minus 10/5 and 40 minus z/5. So here if you see z minus 5, where we have, yeah, medium dot values, right? Step 2, where I have mentioned step 2, yeah. Step 2, yeah. Yeah. Sorry. Output variables, right? The output variables, whatever we have, whatever we got here output, that values we have to compare them. We have step 2 is in the step 3, if you check, we are assuming that if that is medium and grease is medium, then last time is medium. Then we have to go to check here what are the value we are going to get. So now if you compare 3/5 value, right? 3/5 value, we have to take both the possibilities, like medium value, right? Here, see here, medium, step 2, medium, yeah, medium value. So here we have two possibilities. With both the values, we have to equate that value. What are the value? We got medium value. That's what we did here. 3/5, we are going to equate at this value and that value. Then we are going to get some values. So that means that now here we got, here from this we got 19 minutes, from this we got some 31 minutes. So now if we take the average of these two, we are getting the 25 minutes. That means that if the grease is medium and that is medium, it will take to wash the cloth 25 minutes. So this is the way the calculations are going to be done, background of the simulation what we have done. So these are the advantages that we explained as of now for Logic Designer Controller. Advantages are potential tool for dealing with the impression and uncertainty. It does require an extensive mathematical formulation of the problem. And disadvantage also we have, like designing a proper knowledge base is a difficult task and may not be suitable for modeling process involving many variables. Suppose if you have many variables, lot of variables, then it is very difficult to apply in this method. But we have other method that I am going to teach you in tomorrow class. And thank you. I've done with my presentation. Any questions?
Thank you, sir, for the presentation. We have few questions.
Yeah.
The first one is how to enter the equations.
How to enter the equations? No, it's a kind of discrete data. You are not going to dealing with the functions. As I already told you, the things whatever the sir has been explained, that is the only the things, like you are going to express in terms of functions and then you are going to plot. And tomorrow class I am going, and I also show you, if you have a time now, if I have time, I can also show you the data. When you have the data, see, most of the time as an engineer you are going to come across with the only the things of data, right? We need to know how to process that particular data. That's what my aim here. So I'm not dealing with any equations here.
Yes, sir.
This time.
Thank you. And the second question is, why are we taking minimum first and then maximum in due specification?
Here we are applying min-max method. Min-max method. So in min-max method, automatically we have to take the maximum values and then minimum value, right? Yes. Min-max method. For that we have taken the minimum value, then max method.
That's all, sir. Then we already shared the feedback link for yesterday's session. Please kindly fill it.
Still any questions?
Can you suggest research papers related to this topic?
Yeah, many. See, suppose, yeah, good question. See, now I have been showed you the just like a simple model that represents the practically, like what we are going to see in the practically daily. Now today we are facing the problem of the corona, right? Now when you have this kind of data, now the people are saying there are different rumors that have been come across. We have been seeing now every day by day to day news, right? Now anyone can take off the regions of immunity power and what are the sustainability of that particular patient. Those things you can incorporate if when you increase the parameters, so that you are going to get the accuracy, the immunity level, as well as with respect to that. Without, we are not investing anything, right? Just we are assuming that according to your assumption. Then you are making the model. Then what are the possibilities? Or you can, tomorrow talk I am going to just show you by taking the data, like whatever the data we have, just we are going to upload the data, then automatically it is process the data and train the data, and then it is going to give the maximum and minimum values. Then it is going to, whatever the way we have done, the same kind of things has been is going to explain you by tomorrow. Today I have been explained you only the discrete kind of data. We have some assumption. we have been make a model. You have some model. Then you are assuming based on that you are projecting in terms of a G. Then we are getting the results. The similar kind we can also do tomorrow task, that is only data. Like if you have a perfect data, then upload that data and then process that data and then get the output. So that is also there. That is artificial fuzzy neural adaptive fuzzy neural system. So that I'm going to explain you to tomorrow. But if you have like your own assumptions and then you want to make something model, then you can use this one. Even nowadays, digital modeling and digital automated motors and all these things can be done by here also, right? Uh, if they want to continue with these research problems. Hello.
Yes, sir. We have another question. Any basic knowledge is required for doing research in fuzzy?
Yeah, as I already told you, just you need to understand what is fuzzy and what are the, like I told you, right, how this functionality is behind this fuzzy. If you know those things, what is fuzzy, the basic things, because we are not done any programming here. What we are doing, we have an app, like my app kind of thing. We are just going through that, and then we are like we are simulating around according to our assumptions. That's it. You need, if you know the probability and fuzzy basic definition, then it is enough to do the models by using this. Then any questions? You can. Someone asked the slides. Varun, you can keep this slide in our. I have
Yes, sir.
sent you already, right? Just put
Yes, sir.
in that brochure, then they can take care of that. Okay.
Sure, sir. We'll do that.
There are many questions related to slides only. Anyway, you can share that. Any questions from still? Okay.
Okay, sir.
Then we will stop.
Yes, sir.